Questions 1 through 3 are asking you to determine whether the information that they gave is expressed in a mapping, a table, an ordered pair, or a graph. So looking at number 1, I can see my x and my y is displayed in a nice pretty table. Therefore, I know that the first one is a table. Number 2, if I see something with circles and lines going to it, I know that it's a mapping. And number 3, the information given is in parentheses separated by commas, therefore I know that those are ordered pairs. Questions 4 through 6 are asking you to determine whether the information that they gave us was a function or not. So looking at this table here, we need to make sure that there's no multiple outputs for any one input, or simply do the x's repeat. So taking a look at the x's in my table that's given here, I have -6, -4, -2, 1, and 5. None of those x values repeat, therefore yes, that one is a function. Looking at number 2, the mapping here, notice that I have the points 4, -2. I also have the point -1, 3, but take a look at my -5. I have a -5, 3 and a -5, 7, which means my x is repeated. So that no is not a function. And looking at number 3, taking a look at my x's, I have 9, 2, -5, and -3. None of my x's repeat, so yes, that is a function. So the next few questions are asking us to find the domain and range. So remember, domain are always going to be our x values, and our range is going to be our y values. So if it's asking for the domain, just simply list the x values. So I have a 2, -3, 0, -1 for my x values or my domain, and my range is going to be my y values of 3, 4, -5, and 1. So number 9 asks us to rewrite in function notation. So remember, function notation was that f of x. So we can say f of x is equal to, and we are just going to rewrite what they gave us, 2x minus 3. So number 10 asks you to express the mapping as a set of ordered pairs. So notice on my first set of mapping numbers here, I have an x that goes to a y of -2. So my first ordered pair would be 4, -2. And then my next ordered pair would be -1, 3. And the next one would be -5, 3. And my last one would be -5, 7. Alright, number 11 asks us to express the table as a graph. So, you would want to draw some type of coordinate plane here, and my first point is -5, -5. So I'm going to go to the left 5, 1, 2, 3, 4, 5, and down 5, 1, 2, 3, 4, 5, and I can put a point right there. And then I've got -4, so 1, 2, 3, 4, and down 3, 1, 2, 3. I can put a point there. And the next one is -2, 2, 1, 2, 1, 2. Put a point there. And then I have the point 1, -1, so I'm going to go over to the right 1 and down 1. So 1, -1 would look like that. And then 5, 4. So 1, 2, 3, 4, 5, and up 4, 1, 2, 3, 4. So something that looks similar to that. Alright, so number 12 is asking us what the domain is, and remember, the domain is our x values. So, looking at my x-axis here, something that's important to note is that if I put arrows on here, then those lines continue to go on and on and on forever, right? So that means that my x values are going to touch infinitely as the line gets bigger and bigger in the negative value, and also in the positive value as the line extends and keeps going. So therefore, the domain on this one is all real numbers. You can also write it like this, and you can also say all reals. Either of those will get you a right answer. Alright, so the range is dealing with my y values. So my y values, basically I need to see how what numbers are touching on my y-axis, which is this one right here. So I see that the tallest y that I see is right here, and that is at 1, 2, 3, 4. So 4 is going to be part of my range, and it looks like -2 is another part of my range. So writing that, you can say all numbers in between -2 and 4, but if I were to express that algebraically, I can say -2 is less than or equal to, because of the closed circle, and I'm dealing with range, so I'm dealing with a y, is less than or equal to, because I have another closed circle, 4. So I put these two numbers in order. Alright, question 14 is a function notation question. So I know I am going to plug in this 5 in for the x in the original first part of the problem that they gave us. So what that's going to look like is f of x is equal to 2, and instead of putting the x, I'm going to replace it with the 5 minus 7, and then PEMDAS tells me that I need to multiply first, so 2 times 5 is 10, and then subtract the 7, and therefore f of x is going to equal 3. 15 is also a function notation question where we are finding g of x, and we are given g of 2. So we're going to replace that 2 in for any time that we see an x. So we can say 3 times 2 squared minus 2 plus 1. And remember, PEMDAS wants us to do parentheses first. There aren't any parentheses. Exponents next. There are parentheses with, there are exponents with the 2 squared. So we're looking at 3 times 2 squared, which is 4, minus 2 plus 1. And then I'm looking at 3 times 4, because PEMDAS tells me to multiply first. So I've got 3 times 4 is 12, minus 2 plus 1. So 12 minus 2 is going to give me 10, and plus 1 is going to give me a solution of 11. The directions for 16 tell us to factor. So remember, the first rule of factoring is always to look for a GCF. This one doesn't have one, and it has 3 terms. So I can use this X tool. So I'm finding numbers that multiply to 14 because I don't have a leading coefficient here. The add or subtract to give me 9. So if I try 2 and 7, 2 times 7 equals to 14, and 2 plus 7 gives me 9. So I'm going to pull those out, and I'm going to say y plus 2 and y plus 7. Alright, I have another domain and range question. So remember, domain is dealing with my x values and range is dealing with my y values. So we can look at the x-axis first to find my domain. And I notice that on the x-axis I have this point here of 1, 2, 3, 4, 5, negative 5. And the furthest other point on my x-axis is here at 1, 2, 3, 4, positive 5. So because I am dealing with domain, I'm dealing with x, so I can set up my answer this way. And I notice that all of my answers here are greater than negative 5. So I can say that my x, which is like my solutions, where my line hits, and because I have this closed circle, it's going to be less than or equal to. And then on the other side, I can tell that my x, or my solutions, are all going to be less than 5. And it's an open circle, or it's open circle here, so I'm not going to put the line underneath the less than sign. So my range, I'm dealing with my y values. So let's take away this stuff. Alright, so I'm dealing with my y's, so I'm going to find the highest y and the lowest y. And I'm going to set them up into my answer. I see my lowest y is at 0. My tallest y is at 1, 2, 3, 4, 5, 6. and I can see that my solutions, or my answer, where my line is it's these numbers that are less than 6 and greater than 0. So I can say that my solution is greater than or equal to 0. And as far as my 6, I can set it up this way, and notice my open circle and my closed circles. And that's why I put lines under this one, but not that one. Anytime that you're given a line like this and there are arrows indicating that the line goes on forever and ever, it's always going to be, for your domain and your range, all real numbers for both, because it's going to continue to hit every single x value as that line continues on, and then it's going to hit every single y value as that line continues on. 19 is another function notation question. Notice that I am given, one of my problems has an f in it and the other one has a g in it. So that's important to recognize. And it tells me to find f of x plus 9. So I'm going to find the one with the f in it, which is this one. And I'm going to replace my x with x plus 9. So I can say f of x, there we go, equals 2. So instead of putting my x, I'm going to put x plus 9 minus 7. So PEMDAS tells me to multiply first, so I'm going to distribute my 2, and that's going to turn into 2x plus 18 minus 7. And then I can combine these like terms here. So my answer is going to be 2x plus 11, because 18 minus 7 is 11. Alright, so looking at number 20, I have an f of x here, a g of x here, and it wants me to find f of 6 and g of negative 2. I'm going to find those two separate answers and then add them together. So first let's plug in the 6 in for the f of x function. So 2 times 6 minus 7. Alright, so 2 times 6 is going to give me 12 minus 7, and that's going to give me 5. So if we plug in negative 2 in for this g term right here, I'm going to have 3 times negative 2 squared minus negative 2 plus 1. Alright, so order of operations tells me that I need to deal with this exponent, and remember that a negative times a negative is a positive, so that's going to turn into 3 times a positive 4. And this negative, it's like I'm distributing this negative onto here, so that two negatives turn into a positive. So that negative 2 turns into a positive 2, and this is plus 1. So 3 times 4 gives me 12. 12 plus 2 is 14, plus 1 is 15. So I have my two answers that I need to then add together, because the problem told me to add those two. So 5 plus 15 is going to give me a solution of 20. Number 21 is also a square problem, but remember what that means to square something. It's to multiply it by itself. So 2x plus 7 times 2x plus 7. Then I can use the box to do that. So I can set up a box that looks like this. And I'm going to put 2x and 7 over here. So I'm going to multiply these two, and then I go in the top left-hand part of my box. So that's 4x squared. And 2x times 7 is going to give me 14x. Another 14x. And 7 times 7 gives me 49. Now I need to pull out my like terms out of my box, so I only have 1x squared, so 4x squared. And then I'm going to add my two 14x's to give me plus 28x plus 49. Alright, number 22 asks me to find a perimeter of a rectangle, so I always like to draw whatever they're describing. has a base of x minus 17 and a height of 3x plus 7. So I have to remember what perimeter means, and that means I'm going to add up all 4 of my sides. So I know if this side is 3x plus 7, then this side over here has to be 3x plus 7, and if this is x minus 17, then this up here has to be x minus 17 as well. So now let's count how many x's we have. I have 3 here, 3 here. Let's make 6, 7, 8. So I have 8 x's. And then if I am combining my negative 17s, that's going to combine to give me a negative 34. And then I'm going to add 7 plus 7, which is 14. And that's going to turn into a negative 20. So my perimeter would be 8x minus 20.